Okay, this video is to review the Big 20 quiz. The Big 20 quiz has 20 questions that are always the same type of question for each one of those numbers. For like in this case, number 6, which we're going to go over with first here, is always a decimal to fraction question. Convert the decimal to a fraction. I'm going to go through as many types as I can during this class period. Record it and post it to YouTube there. In this case, we're going to start with a number 6 decimal to fraction. We're going to work with this example of 0.43. To convert the decimal to a fraction, we need to count how many place values there are after the decimal. In this case, there are 2. So I'm going to write that same number without the decimal. I got rid of the decimal. I'm going to put that over a 100. Why 100? Because it's a 1 with 2 zeros, 2 place values, 2 zeros. Then I would need to simplify, if at all possible. As it turns out, there are no common factors between 100 and 43, so that is the final answer here. Give another example. Let's say I have 0.005. That one has 3 place values. Yes, you do count them even if there are zeros there. 3 place values. Okay, so at this point we're going to put a 5 over a 1 with 3 zeros because there are 3 decimal places in our problem here. Now both of those are divisible by 5. Anytime a number ends in 5 or 0, it is divisible by 5. So we end up getting 1 over 200, and that would be the final answer here. Okay, number 7 on the Big 20 quiz is always going to be a fraction to a percent. To do that, you first need to convert the fraction to a decimal, which would be bottom number goes into the top number. So 8 goes into 1 0 times. So we put a decimal point here, bring the decimal point up here, put in a 0. 8 goes into 10 once. 1 times 8 is 8. Subtract that, I get 2 left over. Put another 0, bring that down. I've got 20. 8 goes into 20 twice. 2 times 8 is 16. Subtract that, I get a remainder of 4. Put in another 0, because I keep going until this terminates or repeats. Brings this down, I get 40. 8 goes into 40 5 times. 5 times 8 is 40, which gives us a 0. If you had to show work and you stopped and it didn't show this part here, that would be fine, because I can understand at that point if you can do that part in your head. I'm not requiring work on the Big 20, but it is very helpful to do the work to help keep track of things. Okay, now we've got the decimal. Once you've got the decimal, you need to multiply it by 100 to convert it to a percent. So 0.125 multiplied by 100 is moving the decimal 2 places to the right, which helps us with questions numbers 1 and 3 on the Big 20, which is always going to be a multiple of a 10, multiplying by some power of 10. When you multiply by a power of 10, you are moving that number of zeros over, that many place values over. So this becomes 12.5, and don't forget the percent sign. The percent sign must be part of your answer. Quickly though, if I just want to mention, if you had something like 1/3. 1/3, when you do the decimal of it, is 0.33333. It's going to be a repeating decimal. When you multiply that by 100, it becomes 33.3 repeating. And I would accept answers in a percent of 33.3 repeating percent, or 33 1/3%. Yes, you can have a fraction in a percent. That's still fine. Or the answer of 33.33%. This would be my general rule of 2 decimal places. So I'd accept either one of these three in this situation when there is a need to round because of a repeating decimal. On the Big 20 quiz, the number 10 question is always going to be a percent of a number. Sometimes you will have the units of dollars on there, sometimes you won't. To do a percent of a problem, you first convert the percent to a decimal. To do that, you would divide by 100. So 9.5 divided by 100 is moving the decimal 2 places to the left. When you multiply by a power of 10, you move to the right. Divide, you move to the left. I have to put a placeholder 0 in here. The decimal point goes here, and a 0 out here. On a side note, if this was all you were asked to do, this would be unacceptable as an answer because you have 2 decimal places there. You've not the counting places, but you have 1 decimal point here and another decimal point here. The correct answer, if this was all you were asked to do at this point, would be 0.095. Make sure you rewrite it without all of those loops and the second decimal point there, okay? Okay, so we converted that percent to a decimal, then you multiply that by the number. So I'm going to be the decimal version of the percent times the number. So we take that 350 and we're multiplying by 0.095. 5 times 0 is 0. 5 times 5, 25. Carry the 2. 5 times 3 is 15, plus the 2 is 17. Put in a placeholder 0. 9 times 0 is 0. 9 times 5 is 45. Carry the 4. 9 times 3 is 27, plus 4 is 31. 2 placeholder zeros. Well, actually, I think that's it because the next number here is a 0, so it doesn't make sense to go any further with that. Add this stuff all up. I get 0, 5, 12, carry the 1, 3, and 3. Then we go back to the problem. I see I have 3 decimal places in the multiplication, which means I need to move my decimal 3 places over into my answer, which makes this 33.250. Now, this would be acceptable as an answer without units. If you do this without units on the Big 20, if there was no dollar sign there, this would give you 100% on that question. However, if you forget to put the dollar sign and drop this extra 0 on a quiz when you've got that dollar sign, dollars should always be rounded to the nearest cent. So the answer should look just like this when you've got the dollar sign on it, $33.25. There are times where the answer may end up being something like 43.2. And when you've got dollars, your answer needs to be written as 43.20. Okay, money always has 2 decimal places, even if it's a 0 in that second one. Money always has those 2 decimal places like that. Please keep that in mind. Again, that's only if the answer was this and you have the dollar sign up there. Otherwise, this would be fine for the final answer if there was no dollar sign. Number 15 is always going to be about multiplying mixed numbers. One of the biggest mistakes people make is they will multiply the whole numbers, they will multiply the fractions, and then slap the answer together. If you do that, you're forgetting that 1/5 is also going to multiply the 5, and the 3 is also going to multiply the 7/8. So it's a lot more complicated when you break it up like that. It's often a lot better to convert to improper fractions first. So I'm going to multiply the whole number by the bottom and add it to the top. 3 times 5 is 15, plus 1, I get 16 over 5. Then I multiply the bottom, add it to the top, I get 47/8 over here. All right, now I need to multiply. And yes, the numbers are big on top, but trust me, it's going to be worth it in the end here. All right. The bottom, 5 times 8 is 40. The top, I'm going to take off to the side here, 47 times 16. 6 times 7 is 42, carry the 4. 6 times 4 is 24, plus 4 is 28. Placeholder 0, 1 times 47 is 47. Add that, I get 2, 15, and 7. So I get 752. So I have 752 over 40. Now, I know both of them are even numbers. I believe, if I remember correctly, I found out that 8 can go into both of these evenly, so I'm going to work with the 8. 8 goes into 40 5 times, right? So we divide the 40 by 8, we'll get 5. 752 divided by 8, I'll take that off to the side here. 8 goes into 7 0 times, goes into 75 9 times with 3 left over. It's my shorthand for the long division. I do that subtraction in my head and do the remainder over here. 8 times 4 is 32, so that gives me a 0 remainder. So it looks like I get 94 over 5. Then I would do 5 goes into 94, goes into 9 once with 4 left over. 9 goes into 44 8 times with 4 left over. So we get 18 with a remainder of 4. So this is 18 and, 18 and 4 fifths. Okay, I took a moment off recording here to add in the long division here and to rewrite the division here a little bit larger to see it so you can see it. Still not that neat, but maybe it'll help out. All right, for number 11 on the Big 20, it's always going to be a decimal value that you need to round to the nearest place value that they give you. It could be hundredth, it could be tenth, it could be thousandth. In this case, we're going to work with the hundredth. The first place value is, after the decimal point, is the tenth. The second is the hundredth. The third would be the thousandth. The fourth is the 10,000th. Since we're asked to round to the nearest hundredth, we're going to have an answer of 8.4 something. It's either going to be a 6 or a 7, depending on the next number over. Since the next number over in this case is greater than 5, if it's greater than or equal to 5, greater than or equal to 5, you round up. Less than 5, you would round down. Since this is greater, this becomes a 7. If I had 8.4641, even if this was a 4.9, this next value is still less than 5. This would have become 8.46. Rounding down does not make this part smaller. It's called rounding down because you are losing this much value when you chop it off. This is worth less than this whole number here, this whole expression here, because it did chop off this part. You did round down to some extent there. Rounding up goes up 1 for the last place value. Rounding down keeps it the same. Number 12 here is always going to be a rounding to the nearest whole number. Please note I did correct the spelling of hundredth while I was not recording the voice there. Rounding to the nearest whole number. The hard way would be to convert this fraction to a decimal by doing 13 goes into 7. Well, it goes to 7 0 times. 13 would go into 70 5 times. 5 times 13 is 65, which gives me a remainder of 5 there. I could keep going but once I see that I've done at least I know I've got this decimal correct because this value happens to be less than 13. So I know I've got the right number of 13s and 70. Since this is a 5, that would mean that this is 4.5 something. Since this is a 5, though, that would round, the nearest whole number would now round up to a 5, and that would be the final answer. A quicker way would be to look at the denominator. Divide the denominator in half. You divide it by 2. Should be pretty quick to divide most things by 2. 6 goes into 13. So 13 divided by 2 is going to be 6.5. Because 2 times 6 is 12. That means it must be an extra half to get that 13. If your numerator is greater than half of the denominator, if your numerator is greater than half of your denominator, you're going to round up. If the numerator is less than half the denominator, you're going to round down.